Sorry. So can you check? Once again, looks like we had a mess in terms of the audio. Okay. Yes, sorry. Thanks for that. Yeah. So again, luckily we didn't lose much. There's some echo. Okay. Okay. Good. So there are many entry points for system of engineers while they go through a typical design verification process. And borrowing this from the trend chart that's available from Siemens EDA that you see on the top left, there are about 47% people spend time. The bulk of the engineers' time is spent in debug. Then there is also a lot of test bench development effort. There's also test case development effort. And these are two obvious points where engineers are writing system code. And then we would be able to do static analysis using these open source technologies to do debug, coverage closure, optimizations. These are not so obvious for the day-to-day engineers, but this is really where you could take a platform such as svck and then go all the way up to do your regression optimizations, your coverage closure, your debug, and so on and so forth. So what I'm showing you today is not the end of the game. It is not even an achievement, but it's rather a stepping stone for all of you. And the invitation is to each and every one of you who would listen to this to say, what can I do? I don't want you to, applaud what has been done so far, right? I used to work at Intel, and one of Intel CEOs, they said, do not get bogged down by the history. And more so in India, we should really learn that because, of course, we have a long history of many things, but I think probably Abdul Kalam also said that, Dr. Abdul Kalam as well. Let us not get bogged down by the history. Yes, history is great. We have done very good things, probably some bad things, but let's look forward to what can we do from here. That's really what the key message I want to also emphasize today. If there is one slide that you want to take with you at the end of this presentation, that will be towards the end, saying what is that I can do with it. So please pay attention to not what I'm really showing you as in what is already done, but start thinking about what can you do given this live open source technology that's at your fingerprints. Okay, so I'm going to skip some of these slides a little faster because a lot of it is known, and I do want to appreciate the time that all of you are spending your evening with us in India. But these slides are going to be available. You can take a look. But very high level, what we are saying is if you want to do an SoC design today, the cost is anywhere. In fact, 1 million is very, very small today in terms of a chip design. Could be true for an FPGA thing, but $1 million to $100 million US dollars. That is the kind of cost we are looking at, right? So, what are the main costs? Is the tool, the EDA tools, the servers, and etc. And of course, there are global teams split across the time zones. I know some of you are dialing in from the UK, some of you are from Germany probably, and then some of you are, of course, to the rest of Europe, as well as US, and of course, a lot from India, right? So, we do have various time zones the teams are working towards. And the major contributors to the cost of a chip design today is the engineering team cost. Of course, I keep saying that whenever a management complains that engineers are expensive, but of course, engineers should be super expensive because we all need to get richer, right? So we got to go, we deserve more. I'm sure about that, the engineering part. But where can we optimize? Is the open source in terms of IPs, in terms of tools, and etc., which is my personal belief. So, which is what the open source to the rescue. So it's a very nice term coined by Ajita Kumari called BIOL, build your own linter. It's a paradigm shift to what we have been doing in the industry. For those who have been in the industry long enough, 25 years, we have been talking about, okay, there's XYZ tool, there's this wonderful tool that can do linting for you, but you got to pay X number of dollars, and you get, let's say, Y number of rules. And then you apply those 200 plus rules to your code and say what fits you, and then filter those that you don't care about. We said, wait a second, let's step back, understand what is really needed, especially coming from the design verification background, saying, okay, I'm doing UVM and I'm doing, let's say, one piece of it. I want to focus on the code that I write. I don't want to pay for n number of rules and then use only a minimal 10% of those rules right. Instead, you build your own lint. And it used to be very complex. We needed PhDs, we need those folks from special states and universities, and only those guys can do it. But we stopped all that with open source. We said it's Python. Python is almost taught. I was talking to some folks at IIT Madras today, and they said in Chennai, 10th and 11th standard, students are learning Python, and probably object automation is one of the facilitators of these technology deployments. Engineers are, of course, using Python, but even school students are learning Python. So how do we build, using Python, your own linter? That's kind of what the coining of the term by Ajita is on the BIOL, or build your own linter. So while in system Verilog code, you want to find bugs early, and you want to do what is called a shift left, find bugs. And then the linters are needed for RTL, test bench, UVM, assertions, and also acceleration, emulation, formal verification, etc. Now, fast forward again, as I mentioned, okay, good. Let's talk about SVCK. What is SVCK? It is a system Verilog checker. It's an open source minimalist linter for system Verilog code. The keyword is minimalist. Do not expect a full course meal like open road. And it's important to understand, and in an event like this, you're going to get these contrasting views. One person is saying, push a button, you get a chip out. The other person comes up and says, look, we will not give you everything, but we'll give you a platform for you to build. That's innovation, in my opinion. Because they're not saying, oh, here is a beautiful thing. Let's say a big, sitting in Chennai, you could probably say a Raga Alapana or a Carnatic concert wherein the main course is given to you. You enjoy it for next 30 minutes. That's pretty wonderful. Good to have it. But can I also have the small, the tidbits that I could build on my own? That's what the BIOL is, right? The focus is on enforcing style and consistency. And what we do include today is built-in checks for naming conventions, encapsulation practices, as well as line spacing, formatting, and the general code hygiene, right? So some of this is obvious things, and some of it is in fact borrowed from textbooks, such as if you look at the latest book in System Verilog is by one of the experts in this domain called Mark Glasser. He works for Paradigm Works in the US, and he wrote a book, and that book has a small appendix on coding guidelines. That was a tipping point for us. We said, if there is a coding guideline in a book, how do we go and show to the world that you could actually code all of them using a Python layer and then check for yourself, which is what how SVCK was born, right? It's a lightweight, easy to configure, extendable. That's a key word. It's truly extensible. You could extend it the way you wanted it, right? So, and it improves collaboration by enforcing shared coding standards. Let's look at the models. So here is the YouTube streaming as well. So the use models of SVCK is the moment you start coding things. You could be a VS Code user, you could be a Cursor user, you could be an Amazon Q IDE user, or you could be like me, the old guys who do GVM, Emacs, whatever thing. Maybe even Notepad, but I hope people don't code in Notepad. But do open your favorite editor. It could be Eclipse, it could be VS Code, it could be NetBeans, anything, right? So this particular platform is designed and thought in such a way that it would integrate seamlessly with any such editor. How do we do it? I'll talk about it as we go along, right? So the intention is to integrate to enable any kind of workflow. Seamlessly integrates into a CI/CD pipeline, the continuous integration, continuous development, which is what is extremely successful in the software domain for agile software development. You could bring all the practice into design verification today with this. It helps. So it helps maintain the clean. It helps maintain the clean code, readable and maintainable HCL code. Encourages. So it encourages best practices and code-based uniformity. For existing code base, let's say you're not coding any new code as of now, but you do have some old code lying around, or you want to clean up using lint. That's something you could, of course, do. Run the svck on your existing code base to see where the breakages are, to see the code health. Decide what to fix and when. Because we are not here to say you got to do all of this to get all the benefits. We are saying, okay, there are 100,000 lines of code already written, and there's no way on earth I have time to go and fix all of them. I know they are bad. Thanks for telling me, but do not ask me to fix it because I'll never get to it. Fair enough. We rather say, let's enforce gatekeeper rules for future check-ins, which basically means, yes, I know these are good rules. These are good problems that I have, but I cannot fix them all overnight. But can you help me further to say, whenever I write new code, whenever I modify something, can you enforce these rules? The answer is yes. And a sample integration would look something like that. If you look at your that bottom right corner, it's an SVN pre-commit hook, wherein we could say that the pre-commit hook is now added. Any code you check in from now has to adhere to these 10 rules. Otherwise, the pre-commit is failing, which means you cannot check in your code into the system until and unless you adhere to the rules that you chose or your team lead chose. It is not chosen by me or anybody else for that matter. Be it Mar, be it Rajita, be it Sampath. If you like the rule, if your team likes the rule, you can enforce that that code is adhered to, that rule is adhered to before you actually check in the system. So that brings us to the next. So why not use a simple script? Okay, you're saying about, okay, let's say enforce this encapsulation, make sure these are virtual methods. Let's say I have only external methods. I want to make sure I use UVM the right way, for example, the factories and etc. You want to enforce these rules. But I could do this today with a simple script. A lot of us know Perl, Python, and a lot of you know regular expressions. You could do that. But we are saying, do not go around that path because it's going to paint you in a corner and you keep repainting it. Instead, take a step back and use the robust and scalable by design parser. That's from Google. And all of us use Google, most of us at least, if not all, right? Google has built this open source parser and given it to you for free. It's called Variable. I'm not here to sell Google products to you. However, and this is just an example. There's also a similar one called Slang. There's also other open source design platforms available, as well as there are commercial platforms. If you say, I do have customers who say, I love all what you're saying, but I cannot use open source because of my legal department's advice. In that case, of course, you could build all of this using the wordies, the commercial platforms such as Verific, etc. Now, back to what we are doing at svck. It's built on Google's open source variable parser. And it's not an ad hoc regular expression or Perl script. There's nothing bad about it, but they just don't scale. It provides a professional grade parsing and linting capability. This is extremely important. Even if you're a student sitting at Kalasalingam University or anywhere else, Madurai, or anywhere for that matter, you get a professional grade parsing and linting capabilities for free with svck, right? No strings attached. You don't have to even tell us. You can download it, run it today, right? Ensure accuracy and scalability across large and complex system Verilog code base. So it's also modular and customizable. This modular architecture, which is fundamentally what me and Ajita have put together on the svck compared to our previous releases of this, it's an extremely important step that we took. We took a step back and went to the whiteboard, said, this is what is needed to make it completely modular architecture. And this is why I have now interns sitting in US. His name is Himant, and also Yuvan, and also Adrit sitting in the UK. They're all able to add things as simple as, let's say, 10 lines of code, and then beautifully, it's a class-based OOP structure. For those who understand OOP and Python, it is no-brainer that you could extend a class and then add your own rule and then get going. You're not going to break anything that exists. You're going to be adding on top. That's the easy extension and rule customization. We could also do project level customization. and it's ideal. And one thing that is important to understand is that this whole thing works for both design and verification. Though I'm going to talk only about verification, my colleague Sampath will spend more time on the design side. So, this title is right. Sorry about that. But the invitation to you is all, as I mentioned. If you didn't get any of what I said so far, no problem. Welcome on board. Hope you woke up by now. All I want you to take home and then come back to us or come back to yourself is the following. It's a platform for innovation. Do not bother, do not, in Tamil we say this, right? That's how I hope some of you know Tamil, and then you've seen Tirukkural, if you will. So, Epporul yar yar vai keppinum, apporul meepporul kanvadu arivu, right? That's important. Don't bother. I have 25 years experience, this gets 30 plus. Do not bother, because I too believe you guys can do even better than us, right? So, listen to what is being told and then look for your own ways of contributing and interpreting it, right? It's a platform for innovation. You go and build it yourself. Don't believe in others, right? So look at it. It's just more than a linter. You could build wonderful applications on top. It's a foundation for building custom tooling. And seriously mean it. Some of you can do a lot more than what we have done so far. And I want to extend this invitation to all of you who will listen to this. Say, I want to build this extra stuff on top of this and want to publish it in a conference. Go for it. Of course, we would appreciate if you put us a credit note somewhere. But even if you don't, I want you to be happy and then extend and want to have a feeling of I innovated something over the last 3 months or so, right? Something like that. It encourages users to extend the functionality by creating their own apps on the top. It's beyond minting. What you can build is yours. I'm just giving you some hints. And I'll be happy to open up some of these so-called like a summer of code kind of projects. We could do that. But to begin with, of course, custom linters, language servers, the ones I was remember talking about saying, if you're using Cursor, VS Code, IDEs, any of those, VIMs, VIs, pick your poison, as we say, Emacs. You could actually now do all what you're showing you sitting within your editor, favorite editor. You could do custom autocompletes. All that is provided to you through what is called a language server, LS. And again, this is not something that I invented or anything like that. Naturally speaking, variable kind of platforms are easy to integrate with the LS. It has a language server. If you Google well enough, you will find it. If not, drop me a note. I'll be happy to send you a pointer. There are examples done. Similarly, you could build visualization tools. You could build quantitative analysis on top, which is what we are now currently working on. There's a lot of core metrics and complexity scoring on top of your existing massive PCIe whips that we could do, or even at software. And we are here together with object automation and BSS to empower the ecosystem so that it's a community-driven ecosystem that we all start contributing. Of course, we start benefiting to begin with. The moment you benefit and then you start seeing that there is a value in it, I want each one of you to start thinking about what can I contribute. It could be one role, it could be 10 roles, it could be some bold ways that you could do. You could do some testing, you could build some GUIs around it, depending on what technology interests you and then what is the problem specifically you want to do. It certainly should experiment and then automate and then tooling the innovation. That's kind of what I have at the end as a summary. Build your own linter is what we are promoting right now. It's exciting new frontiers, and open source now you can believe that you don't have to spend any money to spend on any of this. And this all doesn't even require a huge server. Most of it runs on your own laptops. And thanks to the Tamil Nadu governments and various governments today, probably central government, cutting across party lines, students are getting laptops, right? True or false, take it this way or that way, but you do have access to laptops. These tools that I'm showing you today and also what Sampath will show you can run on your laptops. And it doesn't hog your memory. It's probably lesser than your video games and even YouTube videos. Trust me, you could do this today. So, and I'm hoping that potentially what set of developers is the reality that should come, especially from a country like India, right? Because we do have a lot of engineers, a lot of enthusiastic folks, and a lot of computer science aware engineers, electrical, electronics, put them all together, we could do something wonderful. Thank you. And that's kind of where I am. Drop me a note. I'll be happy to connect with you and then take it from there. That's the component. Thank you.